Typhoons, also known as tropical cyclones, are fascinating natural phenomena that form over warm ocean waters. The process begins when the sea surface temperature rises to about 80 degrees Fahrenheit or higher. This warmth is crucial because it provides the energy needed for the storm to develop. As the warm air above the ocean heats up, it becomes lighter and starts to rise. As this warm air ascends, it creates a low-pressure area at the surface. Now, here's where it gets interesting. Air from surrounding areas, which is cooler and denser, rushes in to fill that low-pressure void. This influx of air is what starts the rotation of the storm. The Earth's rotation plays a key role here, thanks to a phenomenon called the Coriolis effect. This effect causes the storm to spin, creating a cyclone. As the warm, moist air continues to rise, it cools and condenses, forming clouds and releasing latent heat. This release of heat further warms the surrounding air, causing it to rise even faster. It's like a self-sustaining engine. The more heat that's released, the stronger the storm becomes. Now, let's talk about the structure of a typhoon. At its center lies the eye, a calm area where the pressure is lowest. Surrounding the eye is the eye wall, a ring of towering thunderstorms where the winds are the strongest. These winds can reach speeds of over 150 miles per hour in severe typhoons. The outer bands of the storm can stretch for hundreds of miles, bringing heavy rain and strong winds far from the center. Typhoons typically form in the western Pacific Ocean, where the conditions are just right. They thrive in areas with low vertical wind shear, meaning the winds at different altitudes are relatively uniform. If the wind shear is too strong, it can disrupt the storm structure and weaken it. As these storms move across the ocean, they can gather more energy, intensifying as they go. However, once they make landfall, they begin to lose strength because they're cut off from their warm water source. The interaction with land can also create friction, which disrupts their rotation and leads to a decrease in wind speeds. The impact of a typhoon can be devastating. Heavy rainfall can lead to flooding, while strong winds can cause significant damage to buildings and infrastructure. Coastal areas are particularly vulnerable, as storm surges can inundate low-lying regions. Despite their destructive potential, typhoons also play a role in the Earth's climate system. They help redistribute heat from the tropics to higher latitudes, which can have a moderating effect on global temperatures. Understanding how typhoons form and behave is crucial for predicting their paths and potential impacts. Meteorologists use satellite imagery and computer models to track these storms, providing vital information to communities in their path. In essence, typhoons are a powerful reminder of nature's force, showcasing the delicate balance of atmospheric conditions that can lead to such dramatic weather events. They are both awe-inspiring and a stark reminder of the need for preparedness in the face of nature's fury.